What's up, you freaking geniuses? What's up, you freaking geniuses? So in this video, I'm going to teach you how to find inscribed angles and arc measures on inscribed polygons. All right, so first, we're going to go over a few triangle examples, and then we're going to get into quadrilaterals. So as you can see here, we have this red circle, and we also have this triangle right here, WTF. And we're also given that this angle is 2x degrees, and the measure of this arc out here is 48 degrees. Now, one thing that you might notice is for this triangle, one of the sides of the triangle is the diameter of the circle, right? It's the same exact line. And we know that this line is a diameter because it goes through the center of the circle. Okay, so if one side of your triangle is ever a diameter, then that means your triangle is a right triangle, okay? And the other important part to point out here is the diameter is also the hypotenuse, right? So if this is the hypotenuse, the longest side, that means the right angle of our triangle must be right here, right? Because the right angle is always on the opposite side of the hypotenuse. Okay, so we know that this angle where 2x is 90 degrees. So if we want to solve for x, we could simply say that 2x is equal to 90. So then here we can just divide both sides by 2. So here we get that x is equal to 45. Boom. All right, here's the next example, and we have a yellow circle here with another triangle, right, FML. And we're given that this angle right here, this little one, is 34 degrees. This angle up here is 3x, and this angle down here is 2y. Now, if you notice again, one of the sides of this triangle is a diameter. Okay, so since this side right here is a diameter, again, that means that our triangle is a right triangle. So that means this diameter is also a hypotenuse. So if this is the hypotenuse, that means the right angle is right here where the 3x is, right? So where 3x, that's equal to 90 degrees. So we can solve that one right now, right? So we can, to solve for x, we can say that 3x must be equal to 90 degrees. So to solve for x, we can divide both sides by 3. So we get that x is equal to 30, all right? Now let's find y. Now remember, whenever you add up all the angles inside of a triangle, any triangle, they have to add up to 180 degrees, right? So we know this one is 34. We know now that this one's 90. So that means this angle must be equal to 56, right? Because 34 plus 90 plus 56 is equal to 180 degrees, right? So if this angle is 56, now we can solve for y, right? So here we can say that 2y is equal to 56. So here we could just divide both sides by 2. So we get that y is equal to 28. Boom. All right, let's do one more triangle example, and this one's going to be a little bit different because, as you can see, this triangle, none of the sides are a diameter. Okay, so what we're going to have to do here instead is use a relationship between inscribed angles and intercepted arcs. All right, so just as a little refresher, let's look at 2x right here. So 2x is an inscribed angle. So if you extend the arms of this angle, you can see we intersect it here at A, and if we extend that side, you can see we intersect here at T. So this angle intercepts the circle right here from A to T. And this part of the circle that it intercepts, we call it the intercepted arc. Okay, now, inscribed angles have a relationship with the intercepted arc. Specifically, the angles are half the size of the arc. Or another way you could think about that is the arc is twice as big as the angle, right? So let's ignore this 6y that it gives us right now, right? Let's pretend there's nothing here, all right? So if I tell you that this inscribed angle is 2x, you know that this intercepted arc is twice as big as that. So what's twice as big as 2x? Or in other words, what's 2 times 2x? Well, that would be equal to 4x, right? So another way that we could write the length of this arc over here is by, instead of calling it 6y, we could call it 4x. Okay, but what we've really done right now is set up a relationship, because now we know that this side that's called 6y, we could also call it 4x. Okay, so if we know that 6y is equal to 4x, well, we have another 6y over here. We could also call this one 4x as well, right? Now, the last thing that we have to do in order to solve for x is you just have to remember when you add up all the angles around a circle, they add up to 360 degrees. Okay, so if you add up all the arcs together, they should equal 360 degrees. So let's add these all up. So first of all, we're given 4x down here from f to t, right? And now we also know from t to a, that's also 4x. And we also know from a to f, that's also 4x. So 4x plus 4x plus 4x should equal 360 degrees, right? So what is that? 4 plus 4 plus 4 is 12, right? So 12x is equal to 360 degrees. So to solve for x, we could divide both sides by 12. So here we get that x is equal to 30. Okay, great. Now that we know what x is equal to, why don't we plug it in right here? And that way we can solve for y, right? So if x is equal to 30, well, 4 times 30 is equal to 120. All right, so we get that 6y is equal to 120. So to solve for y, we can just divide both sides by 6. So we get that y is equal to 20. Boom. All right, lastly, let's just go over a few quadrilateral examples. All right, so here we have this green circle, and we have this quadrilateral in here, LMAO. And we're missing these angles, Z and Y, and we're given 120 and 80. Okay, now the rule that you want to remember for solving angles in quadrilaterals is that opposite angles are supplementary. Supplementary, all right? So the opposite angles over here would be, for example, Z and 80, right? These are opposite angles. And when you add those two angles up, they should add up to 180 degrees, right? Same thing for Y and this one up here. So again, these are opposite angles, and they should add up to 180 degrees. All right, so knowing that, let's just start with Y. So if we're trying to solve for angle Y over here, and we know this one's 120, well, that means angle Y, or really this is angle L, but you know what I mean. So here y would be equal to 60 degrees, right? Because 60 plus 120 is equal to 180 degrees, all right? Now, if we're trying to solve for z, again, we want to add it up with the opposite angle. So if this is 80, that means z would be 100 degrees, right? Because 100 plus 80 is equal to 180. All right, here's the next example. So we have a blue circle this time, and the quadrilateral right here inside, right? So it's ROFL, and we're given these two angles right here, 4B, 3A, and as you can see, we're actually missing these other two angles. Okay, so angle O and angle F. So what would be the easiest way to find those two angles? Well, let's start with angle F, just to make this a little bit clearer. So if we're trying to find angle F over here, like I mentioned before, this is an inscribed angle, right? So what relationship do inscribed angles, right? This is the inscribed angles. What relationship do the inscribed angles have with the intercepted arc, right? So the intercepted arc for angle F would be this big arc right here from O to L. So the angle is always half of whatever the arc is, right? So what is the arc from O to L? Well, it gives us that this is 54 degrees, and this one's 130 degrees. So if you add those two up, that's 184 degrees, right? So what's half of 184? Well, that would be 92, all right? So that means angle F would be 92 degrees, right? So we found one missing angle. Let's find the other one. So now we're looking for angle O. So again, if we kind of just extend these arms so we can see where we're intercepting the arc, we can see that angle O intercepts, or the intercepted arc goes from R all the way around to F, right? This right here is the intercepted arc for angle O. And the length of this intercepted arc is 130 plus 110, which is equal to 240. And what's half of 240? Well, that would be equal to 120, all right? So that means this angle, angle O, is 120 degrees, all right? Cool. So we just found the missing inscribed angles, all right? So now we just need to solve for A and B. And to do that, we can again just take the fact that opposite angles are supplementary, right? So these angles have to add up to 180 degrees, and these angles have to add up to 180 degrees. All right, so let's start with A. So 3A plus 120 has to be equal to 180, right? So 3A plus 120 is equal to 180. Subtract 120 from both sides, right? So we get 3A is equal to 60. So here we get that A is equal to 20. All right, great. Now let's look for B. All right, so again, this angle plus this angle has to equal 180. So here we're gonna, I'll write it down here actually. So we're gonna say 4B plus 92 is equal to 180. So if we subtract 92 from both sides, we get that 4B is equal to 88. So divide both sides by 4, right? So we get that B is equal to 22. Boom. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.